Question number 56. Consider the complexes A, B and C. The correct order of decreasing wavelength of light absorbed for the following complexes is. We have the order that's given here. Three complexes we have, A, B and C. We know that. First one is FeCl6, 4 negative. Second is FeH2O whole 6, 2 positive. And third one is FeH2O 6, 3 positive. These three complexes are there, and when we talk about the decreasing wavelength, so in this case we have to just consider the decreasing wavelength of the light absorbed. That depends on crystal field splitting. More the crystal field splitting, less would be the wavelength of light absorbed, because that depends on energy. As crystal field splitting increases, energy increases and the wavelength of the light decreases. Now, if I talk about crystal field splitting, CFS, if I talk about this depends on the charge density on the ligand, charge density on the metal, central metal we are talking about, as well as it depends on the second thing, field strength of the ligand. Now, if I talk about the complex A, in case of A, Fe is there, central metal ion is same in all of these, but the charge density is different. In the first complex, A has iron in Fe2 plus state, while in B, this is also in Fe2 plus state, but in complex C, Fe is there in Fe3 plus state. So on the basis of the charge density, if we want to find out crystal field splitting, then in this case, A and B would have less crystal field splitting as compared to C. Now, what about A and B? If I talk about these two, in that case we have to consider the ligand field strength. Here, in case of A, the ligand is chloride, and if I talk about the B, where the ligand is H2O, which is stronger ligand? Definitely H2O is the stronger ligand as compared to Cl negative. So, definitely in this case, you can mark here that maximum crystal field splitting would be there in case of C. Then there would be the turn for the complex B, and then A would be there. Now, this is the order of the crystal field splitting, and as this is the order of crystal field splitting, then definitely wavelength would have the opposite order, reverse order. So the order of wavelength of light would be opposite of that. It means first A would be there, then B, and then would be the turn for C. Where this order is given? This order is correctly given here in option 4. So just choose option 4 as your correct answer for this particular question. After that, question number 57 we have. Question number 57. The compound which will not show optical isomerism is. We have 4 options given here. We need to just identify the correct option. If I talk about the given complexes, we need to first identify element of symmetry in the given compound. If chiral carbon is there, optical activity will be shown there, but there should not be the element of symmetry. If you look upon the option number 3, you will see that this complex has plane of symmetry, and on the basis of this, it is not able to show optical isomerism. While if I talk about option 1 and option 2, complexes are showing optical isomerism, and that's why I'll choose option 3 as my correct answer. After this, we have question number 58. Major product A of the given reaction is. In this case, we have an alkene and HCl is added to it. We need to just identify the final product that you are just going to obtain. Basically, major product you need to know. In this case, I have the mechanism of this reaction. Just have a look on that. We have the same complex given here. H plus ion from the acid are attacking on this. So, these H plus ion are attacked by one of the carbon, and there is the formation of carbocation. Now, in this case, if you look at this carbocation is comparatively less stable. This is secondary carbocation, while if shift occur in this case, this is a ion and it comes here, shift, then it becomes more stable carbocation. It means in this case there is that results in the formation of more stable carbocation, that is 3-degree carbocation that you are obtaining here. That results in the formation of more stable carbocation, that is 3-degree carbocation that you are obtaining here. After this, the final product that you are obtaining is 2-chloro-2,2-dimethyl butane. So where it is given, if you look at the given options, you will see that this is correctly given here in option 2. So option 2 becomes your correct answer. Just choose it as your answer. After that, now question number 59. The most acidic compound among the following is, we have picric acid, benzoic acid, para-nitrobenzoic acid, formic acid given here. If you compare these compounds, we know that in case of picric acid, we have the 3-nitro group, 2,4,6-trinitrophenol it is. Further, if I talk about benzoic acid, structure is given here. This is para-nitrobenzoic acid, and here is formic acid or the methanoic acid. In this case, if I talk about the presence of nitro group, that increases the acidity of phenol and the benzoic acid. And here you can see that 3 nitro groups are present. In this case, definitely the acidic character is maximum. Even if we compare the pKa values, the pKa value for this phenol is 1.02 only. Less the pKa value, more would be the acidic nature. And if I talk about benzoic acid, pKa value is 4.2. On the basis of this, we can say picric acid is most acidic compound. And that's why you can easily choose picric acid as your correct answer. That is option 1. After that, question number 60. Ethylene oxide, when treated with phenyl magnesium bromide followed by hydrolysis, yields. In this case, we have the Grignard reagent here, and it is going to react with ethylene oxide. What is ethylene oxide? A cyclic compound of this type, and it's going to react with phenyl magnesium bromide. In this case, the reaction will take place. In this case, reaction will take place, and here's the formation of the complex this way. Now further, hydrolysis is done, and that results in the formation of an alcohol. Along with that, MgBrOH, that is released. So what is the product that you are just going to obtain in this case? That is 2-phenyl ethanol, and 2-phenyl ethanol is given here in option 4. That's why you choose it as your correct answer.